I'm trying to.
Thank you, sir.
I have to figure out how to get my screen to show up properly.
Do we have like the Jabber and all the other things set up?
We have a minute taker. I don't know if we have Jabber.
Okay. Let me go check.
I'm trying to get this thing to cooperate. Yeah, well, basically, I'm going to drive the charger and then see if I can get discussion on.
Excellent. I'll leave you to it.
Okay, folks. Oh, this is really set high. Hello, this is the Babel booth, and we're already running late, so I'd like to get us started. And my co-chair is on his way back up. So I see a good number of people here. Thank you very much. And we have a minute taker. Tim, thank you very much. And we have blue sheets that are circulating. Please sign in. It helps us in multiple ways. You want me closer to the mic? Okay, then I can certainly pull the mic closer. Thank you, Margaret. So welcome to the Babel Bath. We're a little behind schedule already, but we've got enough slack. We should be okay. We have a number of presentations to try to cover what is Babel, why are we having this BOF? This is a working group forming BOF. Our goal at the end is to figure out if there is interest and viability for a working group. Before we get there, I have to call attention to the note well. Everything here is part of the IETF. You are saying anything you say, we probably will make use of. People take into account all the ideas they hear. So you're giving us permission to do that. Thank you. If you're not familiar with the note well, please go look at it.
I'm from IETF team.
Yes.
You need help something?
Can you make sure the Miteco works and the Jepo works?
Yes, the web is online. We have just checked that all is working.
Okay.
Okay.
Seems to be fine. So this is the agenda, but I'm not going to bother going through it. It's been up on the web. So Tony's going to present some material to set the stage. I will very briefly summarize the charter, and then we'll go through some content and come back to discussion. So.
Okay, thanks everyone for coming. To set the stage, per 5434, what are we trying to do in this BOF? First, what are we trying not to do? It's not a bar fight, okay? So please keep your tempers. We're trying to be hard on the problems and soft on the people, all right? So let's focus on the problems. This is not a comparison BOF. So all the advantages, disadvantages of other protocols are of no interest, okay? And this is not the attempt of IETF to kill Babel with bureaucracy, okay? This is a workgroup forming BOF, and the intended track is proposed standard, which is very high bar. So we still work with the necessary and sufficient consensus and working code, but because it's PS, the rough consensus has to be a little bit less rough. And we apply what we learned over the last 20-25 years, how to deploy routing protocols on a very large scale, which implies a lot of scar tissue. Okay. All right. And again, since it's a proposed standard, the rough consensus has to be less rough. So lots of the discussions were going around, we have working code and improves everything. That is not sufficient, okay? If Babel gets deployed on a very large scale, this implies for the operators a certain business model with certain margins. So they expect a certain quality. So if we intend to put a PS IETF sticker on it, we'll have certain processes to apply. Okay. So after all those, what it's not, what do we try to get out of here? Okay. We have to see whether we have here a proposed charter that we can agree on, upon which a working group can be formed. We have to see whether there is enough interest to get this work done. So a PS work group preconditions certain amount of documents, and these documents have to be produced in a timely manner at the specified quality. That means that a good amount of people will have a good amount of work to do. If those people are not here, then it will be simply hard to get the working group to a conclusion. Beside that, we'll be looking at a couple of technical issues, gauge general interest. On technical points, we'll have some discussion, but this is not the place where we solve all these technical issues or get the working group work done, okay? All right, and it's back to Joel.
So, as we said, the focus here is on driving the to a conclusion as to whether we are ready and able to form a working group. The eventual conclusion belongs to the IESG and our relevant ADs. Our job is to see what this room and the people on the list consider. So I'm going to very briefly summarize the charter we have available, just so people have it in their head as they look at the technical discussions we're going to have going forward. Then we'll come back to this. So there's no point in discussing the details of the charter right now. This is just stage setting. So the key is there are RFCs out there that we're working from, 6126 and 7557 on the basic protocol mechanisms. There's a separate discussion on security, which we definitely have to address. We're going to have to address manageability as well. People have all sorts of opinions about how we do that, but we have to address it. It's part of the process. So this is the list of work items that are in the proposed charter, and we'll come back to them later. But we're not just doing, just get the PS, but we're going to do things like explain what the implementation experience is, because we've got some real experience, and that's useful to folks. We're going to publish the applicability. Yes, Julius has a starting point that he'll talk about. That's going to have to become a full-fledged draft that we as a working group work on if we go for proposed standard. And that is the introduction to that. And so now, Julius, if you would come up, the pink box is where they want presenters. And just let me know when you want page.
Hello, so I'm Julius Krobacek, and I'm the original.
Get that mic up and pull it. Try to be a little closer to it. They're having trouble with people hearing.
Okay, is that right? So, is that fine? Okay, so that's slide 6.
You insisted on paging forward until I stopped.
Okay, so I'm Julius Krobacek, and I'm, and in 2008, I originally designed what was to become Babel. Next slide, please. Okay, well. No. Yeah, but it's black.
It's completely blank.
That's fine.
That way it doesn't have to look up there.
Teleprompters now. Next slide, please. Okay, so I was asked a few weeks ago whether I could do a first draft of an applicability statement for Babel. And I said, okay, so it's a routing protocol, and so it's useful for routing. And apparently that was not good enough, so people told me, okay, try again. And so, okay, I sat down, took my pen and my quill and a piece of parchment, and wrote a first draft of an applicability statement. But before I summarize it, I'd like to give you a little bit of background. So the applicability of Babel is linked to the properties that it has. And I think that it has 4 important properties. One is that it's a robust protocol. One is that it's flexible and extensible. One is that it's easy to implement. And finally, it has a very cool logo. Next slide, please. So what does it mean to be robust? Babel, most routing protocols give you very strong properties of convergence and how they behave after convergence. Babel attempts to give you strong properties about what happens all the time, even before it has converged. Babel is pushing packets in roughly the right direction, and it guarantees loop-free paths. The idea is that if you're pushing packets roughly in the right direction and never looping, there's not really much that can go wrong. So those are strong guarantees even before you have reconverged. The second property is that unlike many more refined protocols, it does not attempt to really minimize the amount of control traffic. It relies on periodic updates and timeouts. So if there is incorrect data in your data structures, it will eventually get cleared either by the next periodic update or, in the worst case, by the next timeout. So with Babel, you're a little bit less nervous about having untrusted implementations in your network. A buggy implementation does not break your whole network. It just breaks things locally. So that's a rather strong statement. In a very early version of Babel, we were actually corrupting our data structures. And we could see it in the routing tables. You would sometimes have a root pop, a phantom root pop in and disappear after a few seconds. But actually, the users of the network never noticed because there were no packets being routed according to those phantom routes. I was corrupting buffers. I'm not very proud of myself. Next slide, please. Okay, Babel is flexible and extensible. What that means is that if you have two implementations of Babel with different parameters, different hello intervals, different update intervals, different behavior, then they will interoperate. So technically that's achieved by having all the parameters explicitly in the data protocol. So if you never receive just a hello without knowing when is the next hello, you know exactly when the next hello is being sent because the time is in the packet. Same thing for updates and so on. So everything is explicit in the protocol, and that allows implementations to adapt to each other. Implementations with different algorithms interoperate as long as the two fundamental algorithms, loop avoidance and starvation avoidance, aren't broken. So there are two pieces in the protocol that you know you're not allowed to touch, because otherwise you'll break everything. And other than that, all the rest, route selection, use of metrics, and so on, is something you can change without breaking interoperability. And finally, the packet format has plenty of space to carry extension data. And, well, this is something that we've shown because there are a number of extensions that are currently being deployed. There is RTT-based routing, I'll say a few words about it later, radio diversity routing, and the one that I find most interesting, which is source-specific routing, which was implemented by Mathieu Boutier. Next slide, please. Finally, Babel is implementable. So I think that's an important property of any protocol and something that's often neglected, how easy it is to implement. So Babel makes no changes to the data plane. It's just a routing protocol that manipulates your routing tables. So if you're implementing it in software, you're just manipulating the kernel's routing tables. If you're implementing in hardware, you're just manipulating the routing tables with the forwarding tables of your hardware. It has a small, and I like to think, readable spec. So small, it's because I don't like writing much, and readable, it's because it was reviewed by Joel. And, well, that's character forming. And it has less than 40 pages that are normative, including the extension mechanism. And there are two independent re-implementations, one done by Marcus Stenberg, who unfortunately isn't here, and one done by Toki, whom I've seen somewhere here. So Marcus did his implementations in 2 nights, and Toki took, I think, a week or a little bit more. And the smallest implementation, which is Marcus's implementation, is just 700 lines of Python code. And the large implementation with all extensions and with all the bits that remain of the experiments that failed, but that we didn't entirely remove, that's 10,000 lines of C. Next slide, please. So rather than telling you about all the problems that Babel is going to solve, so I'm enthusiastic about Babel, and if I let myself go, I will explain to you that Babel will solve all the problems in the world, including world hunger and anything. So I'm rather going to tell you about the application areas where Babel has already been successfully deployed. And I'll just say a few things afterwards. Next slide, please. So Babel works relatively well in a classical prefix-based network. Okay, it doesn't work as well as OSPF, ICES, because that's not what it was designed for, or EAGRP, because those are not the networks, but it has reasonable behavior, and it has all the features that you'd expect from a protocol, such as the ability to do aggregation or to do filtering. And it works reasonably well in pure mesh networks, where you have, non-transitive links, where you have unstable links that you need to dynamically probe, and so on. And it's the same protocol that works reasonably well in both cases. So what that means is that it works well in hybrid networks, networks in which you have parts that are prefix-based, that are ordinary, Ethernet networks with prefixes, and parts that are of a more meshy, more unstable nature. So I think that makes Babel quite unique, because that is a space where you have a single protocol, a single routing area, routing domain in which both kinds of network links are present. That's something that's fairly rare. Next slide, please. The other successful kind of deployment was for global scale overlay networks. So a company called Nixity is deploying data centers all across the world and putting hundreds of tunnels between them. And what they want is to just put a routing protocol and have their network work and preserve connectivity, notwithstanding the outages of individual links. And what they found out initially was that they would have a nice topology in which they had 3 data centers in France and the data was going here. And then the link between Lille and Marseille would break. And they would find that the routing protocol would sometimes decide to route the data through Tokyo. And that was not very optimal. And so what we did was that we added a metric to Babel that was measuring RTT and deducing a metric from that. Now, usually, your reaction should be RTT will lead to oscillations. There is a negative feedback loop, and that will lead to oscillations. But so in such a situation, you risk never converging. But that's not really a problem for Babel, because it is still pushing packets in roughly the right direction according to loop-free paths. I'll reassure you, we have put in quite a few mitigations for the oscillations. Next slide, please. Okay, finally, Babel has what I think is among the best supports for source-specific routing, and that makes Babel, suitable wherever source-specific routing is needed. In particular, I would like to underline the fact that Babel source-specific routing support interoperates to the extent possible with normal Babel. Next slide, please. And finally, so Babel is a small, simple protocol that requires, in many cases, no configuration, given the current implementation. And so I'm having quite a lot of feedback for people who are using it as a RIP replacement. In this kind of trivial networks with 3 wires and 5 routers, and you just want to put a routing protocol and be done with it. It works perfectly well in that case. Next slide, please. Now, I would like to tell you about an application area where I think that Babel works reasonably well, but the niche is already taken. That's pure mesh networks. So we have been having yearly friendly competitions with other mesh routing protocols. And I don't want to get into the details, but shall we say that Babel has been shown to be competitive with dedicated mesh routing protocols. It's better on some tests, worse on others. Now, that's a particular area in which there is a perfectly good protocol that is an IETF standard. That's OLSRv2 with the DAT metric. That metric is experimental. And so this particular niche is already occupied. Next. And finally, there is one area in which I would not recommend Babel. It is huge, well-administered networks. So there are a number of protocols, the best known being OSPF, ISIS, and the AGRP, which have been beautifully tuned for this kind of networks. They only transmit deltas. They create an amount of control traffic and stable networks that's absolutely minuscule. They scale beautifully. And Babel relies on periodic route announcements, which I think is a good thing for the application areas that Babel is designed for. And so it will never be competitive with those protocols that only send deltas. Next. I have the conclusion slide. You're skipping it?
No, sorry. I was reading the numbers and thought we were on the last one. I'm very sorry.
It's okay. Well, thank you very much for your attention.
If there are
Thank you very much
questions,
for your
please.
attention. So hello, I'm Julius Krobacek. And well, so if Babel is to go to standard track, some things may need to change. Next slide, please. So there are some changes that are, so I think it's sometimes useful to restate the obvious. So this is one of those slides that restates the obvious. There are some things that are bugs, and they need to change. Some things it might be a good idea to change. Other things might not be it might not be a good idea to change. And there are things, if you change them, this is no longer Babel. It might be a pretty good routing protocol, but it's no longer Babel. Next slide. So I have a 45-minute talk that gives a technical introduction to Babel. This is not it. I realize that many of you are busy people, so this is a one-slide technical summary of Babel. So if you want to build yourself a Babel, you start with naive distance vector, RIP. Okay, and so you take RIP and you add to it a proper protocol for neighbor discovery. So RIP has this weird feature in which root updates are overloaded. If you receive a root update for somebody, that means that he is a neighbor of yours. And the fact that root updates are overloaded creates a certain number of problems in RIP. So in Babel, you have a hello protocol like you're used to from any modern routing protocol. And then you add to this an extremely strong loop avoidance algorithm. So it's not absolutely perfect. It does not guarantee the absence of loops in all cases, but it is stronger than any loop avoidance protocol known to me, any loop avoidance algorithm known to me. And once you have this loop avoidance algorithm in your protocol, then you will suffer from spurious starvations. You will suffer of situations in which you have some roots. However, the loop avoidance algorithm cannot prove that any of those are loop-free. And at this point, you need to solve your starvation. And so you have a starvation avoidance algorithm, which is somewhat inspired by similar algorithms in DSDV and AODV, but there is a major difference, I don't want to get into the details, which makes it faster while still being complete. So if there is a loop-free path, it will be found. That's a theorem. Next slide, please. Okay, so in designing Babel, I've realized, so that's something that I've realized afterwards, I have followed a number of rules. And one is that whenever possible, you want to build your features into the data structures and the algorithms rather than adding ad hoc mechanisms to have the features that you want. And I'm rather serious about that. This is the reason why we're at Babel version 2. I started counting at 0. There have been 2 incompatible revisions because I started adding a mechanism and realized that by changing the data model, by changing the data structures, I could make this mechanism completely spurious because the property became built into the data structures. So that implies that if a mechanism is not needed, don't include it. And if a mechanism is needed, we try to make it as simple as possible. We don't try to generalize from just one example, or even worse, to generalize from no examples at all. Next slide. So here's a simple example of how that looks. One thing that people are using are routers with 2 radios. Now, usually those 2 radios are tuned to different radio frequencies. They don't hear each other. And that's what the diversity extension is for. But sometimes people tune them at the same frequency, in which case a node will become a neighbor of itself over the link between the 2 radios. Now, my first reaction when I saw that was, well, you need to get rid of this particular case. But it's not needed. All you're getting is an extra, is a spurious entry in your neighbor table, because the loop avoidance mechanism will immediately discard. It will never even consider a route that goes across this link. So all you're paying is a small entry in a data structure. Next slide, please. So another example, so that's speaking about not generalizing abusively. In Babel, we carry time intervals, and they are encoded as 16-bit integers in units of 10 milliseconds. So that gives you a granularity of 10 milliseconds, intervals up to 10 minutes. Great, that serves the need of the basic protocol. Now, in the RTT extension, we needed to have high resolution time. So what we did was to simply have microseconds in a 32-bit field. It's easier to parse two different, very simple representations rather than have a very general representation that solves all the needs of everyone, but is very difficult to parse. Next slide, please. So to come back a little bit to the specifications, so the specifications have served us well. One of the people who did independent re-implementations of Babel said, I'm quoting here, "The spec seems clear enough." Now, we keep a list of known bugs and omissions, and right now it is 4 entries long. And we also keep a list of things that weren't clear to the implementers, and that's much more precious than the list of bugs. Because when you see a bug, it remains a bug. When it wasn't clear for an implementer, 2 months later, the person doing the implementation will tell you, I don't know what I was thinking, it's perfectly clear now, because he has grown into the protocol. So that is something we keep very preciously, and it's not much longer. Next slide, please. I think, so one thing to consider would be to think about editorial improvements. So one thing that should be considered is merging the extension protocol, which currently is a separate document, into the base document. And a number of people have mentioned that some of the requirements might need to be tightened. For example, what happens when you receive an incorrect packet. Next. And I've heard a number of suggestions for the protocol. I'm not expressing an opinion here. So things that have been suggested were, for example, forbidding some values for router IDs, expanding the size of metrics, adding a transitive bit, cleaning up the packet format, great opportunity for endless bike shedding. Those are things that will need to be considered by a Babel working group. Hopefully, the working group will be able to keep the Tower of Babel in mind. Slide, please. I don't really have a conclusion here, so I'll just end on an optimistic note. I think that a standard track Babel is something that we can achieve in finite time, and if we're careful, it will still be Babel. Thank you for your attention.
Thank you.
No questions, though. That was so good or so bad that there are no questions.
We've got a question. Julius, just state your name, please.
Hi, my name is Uma from Ericsson. It's a very good presentation. Thank you. I heard a lot of meetings in HomeNet, but I couldn't get the full grasp of Babel protocol. Thanks for detailing very well. But my question is, what are the major problems you wanted to solve in this protocol if working group is formed? And what are the future extensions you foresee to be added?
So the question is, what were the problems that I wanted to solve with this protocol?
Yes.
So I wanted a simple implementable protocol that was suitable for hybrid and highly dynamic networks. Hybrid meaning that you have stable links, unstable links. Highly dynamic means that things break and you want the protocol to behave well, even at the time when things are breaking, unbreaking, and so on. And you had a second question, which I didn't catch.
The extensions, what are the future extensions? I saw a few extensions you told already, like source-specific routing and other stuff. What are the future extensions you foresee? Based on the current deployments or in future, what deployments you foresee this?
So I've been trying as much as possible to implement things that my users wanted, to avoid implementing things just because they are fun to implement. Right now, the next request, and I'm waiting to see whether it's a serious one, is for TOS-specific routing. So routing packets differently depending on how they are marked in the DSCP field. Okay, I'm waiting to see whether the people are actually need the feature and they're not quite sure themselves. The application would be to, route some packets over the global internet and some packets over an
But
MPLS link.
I do want to clarify, let's not get hung up on detailed extensions because frankly, that's not in the charter. At least it's not in the proposed charter.
One last question is, you didn't touch base on the security aspects of it. Probably there is a separate draft for it, but you didn't touch base at all here.
Well, there's a presentation discussing the security issues coming up in a little while.
Eric Nordmark. So you mentioned briefly that Babel can interoperate with these different extensions to the extent possible, like source-specific routing can interoperate with the regular destination-based routing. So this, to the extent possible, is there a place where I could go find out more about that? Or is there a short? You said that they can interoperate to the extent possible. What does that mean? Right?
Okay, so, perhaps I'll give a simpler example. Suppose that you have one version of Babel that is able to carry IPv4 and IPv6, and the second version of Babel that only does IPv6. Those two implementations will successfully exchange IPv6 routes. Obviously, they will not exchange IPv4 routes because one of the two implementations doesn't do IPv4. Right?
Okay.
Same thing with source-specific routing. What we do guarantee is the lack of loops, and we do guarantee the fact that there exist topologies that are easy to check for, in which you will still get routing to the right place. Okay, but obviously, if you don't have enough source-specific routers in a network, you're not going to be successful at source-specific routing.
I think I have to go read something, but okay.
Manuel Bocelli, INRIA. Thanks for the nice presentation. Made me think of some aspects that happened a few years back in the IETF. So in the OSPF working group 4 or 5 years ago, there was quite a lot of work on some OSPF extensions, specifically targeting wireless mesh networking.
Which working group?
OSPF?
Yeah.
And which were basically targeting hybrid networks, such as the one you described. So I don't know which level of dynamicity you're thinking about, so that it remains to be seen. But I was just wondering, like, about these OSPF extensions, like what advantages or disadvantages do you see based on what you were aiming at with Babel?
So I'm familiar, so I have looked at the OSPF extensions for mesh networking. All I can say is that in principle, I think that both kinds, there were two if memory serves. There are three? Okay, so I've seen two. Of the two that I've seen, it looks like in principle they should work. I haven't seen any experimental data. I've seen a lot of simulation data. I don't have a clear opinion. So that doesn't contradict what I'm claiming. I said it's fairly unique. I didn't say it's absolutely unique.
I think there was some experimental data that we need to read up in maybe.
Okay, we do need to move on, but so take this last question and we'll move on to the next presentation. Go ahead, sir.
NOI from ENW. It's not a question, it's just a comment for the gentleman who was asking what the applicability niche of Babel might be. I'm involved in some community wireless mesh networking. And in the community where I'm involved, we have like 1,500 nodes right now, and OSIR was not an option for manageability reasons. Right now we are doing Batman, but that doesn't scale well. So we have high hopes as for Babel. That is what we are looking into. And I know that other communities in Germany do the same thing. So I would very much appreciate this becoming.
Thank you.
Thank you.
Okay, I'm Ted Smaller. So I'm Tony P. And I got involved to trying to herd cats a little bit here as a BOF chair. And I ended kind of looking at Babel through the PS track working group lens, right? Which is, like I said initially, has its own requirements based on a lot of scar tissue we had with deploying protocols and rolling a lot of trucks and rebooting lots of routers, right? Times has passed, we can have a Cisco employee slip by a router, sorry, no, a company's employee slip by the router, right? So if Babel has to go major leak or the going gets tough, I put a couple of observations. Those are just suggestions, observations, and they basically serve the purpose of what would have a work group to do, right? I'm not having a solution here. So first observation was, will Babel work? Yes, it will work. Okay, so it's not fundamentally broken. So if we start a working group, what am I talking about? What would have to happen to make it solid PS, right? To put an IETF quality sticker on it. So first, the document quality, right? This thing is coming off experimental track. It has its holes, right? This was just implementation, people documenting implementation. It's doing actually a pretty reasonable job. If it go PS, there will be certain quality requirements, and I'll talk about those a little bit more detail. My observation was that it is full of fairly cool novel ideas, right? And it has been deployed to some extent. 2 implementations exist, actually 3. But it goes into something which will be very unstable. I mean, the claim to fame would be that it can cope with networks, possibly on a smaller scale, but it can cope with networks which will be far less stable than what we are used to. Okay, basically the whole precondition of building the thing is that he's operating on network, which will have the modern properties, right? They reconfigure all the time, they Wi-Fi, they do all kind of crazy stuff. So there, my observation was that simulation will be probably very valuable. And I know that Mane was doing some stuff and it will be up to the chairs and people like Julius to pretty much herd the cats to do the relevant simulations, right? And probably the community to feed the real data, like the German Wi-Fi deployments. All right, then, throwback. So then the other observation that I had was that Babel is an open source community, which is great, okay. But the argument that the reference implementation is equivalent to specification will not hold from our experience, long-term experience. So I talk a little bit about that. I found that the extensibility that Babel wants to achieve pursues some pretty novel tracks, okay. So the first thing would be to define what is a Babel baseline and what is optional, what is mandatory, to put it out as a PS, right? So that's a discussion that the working group that's part of the charter, and that's a discussion that the working group would need to have and converge on. What's the charter, and how far does the charter stretch, and what is to make it a PS document, and what are the optional things to work further on? Good. And the usual trade-offs will apply, right? Good protocol is something where you have nothing left to remove, but at the same time, you want the protocol that can be extended for 20 years without forklifts. And we had our experiences with that. All right, so that's kind of like setting the theme. So reference implementation is not PS specification. Specification is not just an implementation guideline or even an over-specification. So we learned that, right? So I just give 2 examples. I went looking at implementation, tries to like loosely implement it in my head, reading through the document, could I implement that, having done it, good amount of times for a lot of protocols. So I found, one example was in 3812, where the sequence number modulo calculation didn't have a reference, and reference implementations were wrong, right? So that's what the spec was to lose. So I'm playing into the theme that a spec is more than just a reference implementation, right? So that's where the working group will need to focus to get to a PS status. And the second example I found is that I tried to figure out how the packets are processed. And I could somehow cobble it together from the reference implementation, but the implementation doesn't give you the musts and the shoot and the maze, right? So the spec had a shoot where it is a must, in fact, right? So strictly speaking, someone naive enough, because I didn't participate in the bubble discussions from the early days, would stumble. And the rules were spread across the spec, and actually I could not reconstruct in my head of whether all the cases have been treated by the document. Obviously, implementation treats all the cases, right? I mean, worst case, it crashes. Or otherwise, it just does something people didn't think about. But the spec didn't have a full treatment of the packet I could reconstruct in my head. Next. All right, so those were examples. Then I have more observation is that the glossary was loose. Okay, I found a lot of IDs, router IDs. I ended up going to reference implementation where you find those things, right? But ideally, a spec should stand by its own. I didn't find any constant values, right? So from experience with a lot of protocols, if you just drop them out there and everybody configures any kind of value, how do you know the whole thing will interoperate? Because the tau of the Babel is good, but if you go PS, standard track, one of the most important attributes is that the bloody thing interoperates. No matter which vendor you throw in what network, out the box, you push the button, and that thing better interoperates. And if there's no constant values in the spec, who knows what the hell will be on the boxes? And if it hasn't been simulated and tried, how do you know that any combination of any crazy value that people put on those boxes will actually end up interoperating? Okay. I mean, those are generally, I mean, those are not unfixable things. This is like, how do you take it from what it is today to a solid PS protocol? From the experience that I could not reconstruct in my head the full packet treatment easily, we made very good experience with string numbering of clauses, right? When it went to routing protocol processing. Sexy? Nah. Boring, tedious crap. But then when you have complicated email discussions, you end up in referencing the clauses very, very strictly, down to like the fifth, capital I, A dot, whatever. And those are things that melted networks. We saw that over 20 years often enough. The spec omitted completely error handling of misformatted packets, and we had our own painful experiences with that. And the spec suggests a fairly cool, novel, probably interesting to try packet compression, all right? But then the packet compression, because it's so smart, we introduce more interesting error cases. And then again, how do you know that if you drop someone's into the network and they start to corrupt packets, that the whole thing will not loop up on itself? Okay. So the other desirable property of Babel is the flexibility, right? So it allows for metrics which frankly we didn't know how to run, like the RTT, right? Or like the diversity metric. We didn't have much of a clue, and it was beyond no experience in practical sense. We didn't have any theoretical understanding whether the whole thing will work, and it seems to work, and the metrics seem to be workable, but again, for the interoperability, a PS should suggest one or two metrics that you drop out of the box into the network and the stuff works. And the rest is cool and sexy and so on. So if the working group would go towards the direction of 2 or 3 metrics, they end up with the problem of ensuring that any combination of any of those metrics will work out the box, okay? I was looking at requesting the new route procedure. For a PS, I suggest to do a good amount of simulations. I found things that I believe will oscillate. It does not mean that the protocol will not work. It will work, but it will go in oscillation. And something like a hysteresis that will work out the box will probably need specification, because if something is implemented without a hysteresis, bad things will happen. Next. So what's the baseline? What are extensions? That's something the workgroup will have to tackle. So one of these things is a multicast, right? The HomeNet, which would be applying it, specifies specifically multicast support. So it's interesting, right? I have no opinion. Should it be on the charter? Should it be after PS? Should multicast be excluded from the charter? ECMP. I already had people coming up actually this IETF with pretty crazy ideas how to use Babel in a good sense, but they wanted ECMP. What was the other thing? The TOS, yeah. The security, elephant in the room, The world is not a nice place like it used to be 95, 97, right? We have people specifically looking to break and attack things. So that's no workgroup charter. And what is it? Is it the PS baseline? Is it the next thing to deliver? Okay. I looked at the formats. So I suggest a couple of things like 32-bit metrics, but that's something for the work group to discuss out, right? The 1 byte TLV length in ISIs have proven a pretty serious problem with extensions. The new TLV for everything and ignore everything else is simple, but I didn't see how that would deal with the optional transitive approach, because it will need basically to a combinatorial explosion of new TLVs. I'm not saying it shouldn't be done the way Babel is doing. I'm not saying I have a solution, but I think that's something that the work group has to chew through. So it has been thought through and committed, and then that becomes PS rather than just going down the path. Okay. Lack of error handling came before. Next, please.
There is no next. That's right.
Oh, okay. So I have no conclusion. Well, the conclusion is simple. I think it's full of good new ideas we didn't have the energy or guts to tackle. Okay. It will work. It needs some serious chewing through a proposed standard working group. Good. Thanks very much. Questions? That was so good. No questions. All right.
Hello, my name is Toki Hyland Jørgensen, and I'm one of the people who have done an independent implementation of Babel. And I'll tell you a little bit about who, what, why, when, and how I did that. So my background is I'm a PhD student at Karlstad University in Sweden, and I've been involved in the Bufferbloat and Server router firmware project. So I haven't really done anything concerning routing before, other than I've been running the reference BabelD implementation on my own networks. And this has actually been my first exposure to routing protocols at all. And I've been lurking in the HomeNet sessions for a couple of years and following the discussions, but mostly from general interests. So what I did was I added support to the bird routing daemon for the Babel protocol, and that is the IPv6 part only, and no extensions. So this is all based on reading the RFC that describes the protocol. I did see Julia's presentation in Prague, which was the 45-minute presentation he was referring to earlier, but the implementation itself I based on reading the RFC itself. And so why would I do this? Well, as I mentioned before, I didn't really have any experience with routing protocols before, and what better way to understand a protocol than trying to implement it? So why on earth not? And so this has sort of been my journey into routing, you could say. I also wanted to see if it was feasible to do an independent implementation that was fairly complete. And of course, I also wanted to practice my C a little bit, because I'm a Python programmer, and bit operations and all these kind of things are scary and difficult. So this was my first major C development project, I guess you could say. And so I started this doing one of the Battle Mesh conferences last summer, and it took me about 2 weeks to get the initial implementation, which I then posted for comment on the BERT mailing list as a patch to the BERT daemon. And then I had to go and do a partial rewrite of the thing, because memory alignment, what's that? And this was actually, my main issue with the implementation, and the main thing I had to change was actually more because of language things than it was because of the spec. And then, so this has been going on in the period since. A few remaining issues were fixed on the second review last week. I just submitted a V3 of the patch today. And hopefully this will actually go into the BERT routing daemon and be part of the 1.6 release. So, how did it go implementing all of this? Well, I found that the base spec was very readable. The section 2 of the spec gives you sort of the background and explains why is it doing all this, how is it working on a sort of on a more conceptual level, and then sections 3 and 4 are really all you need for the details of how to implement the protocol. So it's very short, it's very readable, and it's easy to go through, even for someone like me who did not have a background in routing. Having the BERT daemon to implement this in helped me a lot, because then I didn't have to invent a lot of fancy data structures. They were sort of already there for the fib and so on. And a lot of I didn't have to write code that interacted with the kernel either, which was also nice. So I was happy of having this way of doing things, and I could sort of look at some of the other protocols that are in BERT and see how they interact with the core of the daemon. Now, while I was implementing this, there were some subtleties in the Babel protocol that required a bit of clarification. But this was resolved in fairly short order by going onto the mailing lists and asking questions and so on. And then, of course, the code review during the patch submission process caught the remaining issues. And these clarifications fall into 3 categories, basically. So errors and omissions in the spec, and things that were a little bit unclear. And Marcus Stenberg has been kind enough to supply me with his notes from his Python implementation as well. So the lists on the following pages is sort of the sum of all our difficulties that we had in implementing this. So actual errors in the spec, the only thing that was wrong in this sense was that the port number was wrong, because apparently we both managed to miss the link to the iterator that changed the port number to what is actually running, and we both started implementing things and wondered, why is the official Babel daemon speaking on a different port than what the spec says? So that was sort of the only error in that sense in the spec. Then there were a few omissions that we had to fill in ourselves and get clarification on. One was the local metric functions, where there's an appendix that describes some functions you can use, which is what I just did and went ahead and used those. There's also the sequence number space that Tony also mentioned, which I at least initially got wrong, but which then came up in discussions and was fixed. Error handling on validation failure. What do you do if the first TLV in a packet is malformed? Do you drop the whole packet? Do you just ignore other TLVs of the same type? There are some interactions between different types of TLVs, where one will specify a router ID that is then applied to subsequent updates in the same packet, for example. So if you can't pass that root ID, you should probably not pass the updates either, but it's not specified. So I think I was just being conservative and dropped everything as soon as I ran into an error. And then there was the root IDs. There was some, how do you map them? There's a mechanism to map root IDs from addresses. How does that work 5PP4? How do you handle collisions, and so on. Then there were a couple of sort of other issues that weren't really omissions, but that were actually described, but that wasn't clear enough, apparently, because one or both of us missed them during the implementation. One is, why is the black hole routing the propagation to, you propagate unreachable routes to the kernel when you black hole a route? Why is that needed? And that's something that's a little bit unusual, apparently. And that is discussed to some extent, but it took a couple of iterations to figure out why was that actually needed. Then there's the fact that you can stick extra things at the end of the TLVs, which isn't there, but is possible to miss also. And then there was the same thing that Tony mentioned with different, a bit too informal language with IDs, router IDs, neighbor IDs, and what are they in different cases, where you had to read through the text a bit and guess. And then also the fact that you can't just check if the root ID field, when you're passing, root ID 0 is actually valid, so you can't just check if it's set to see if you've gotten a root ID, that sort of thing. So in summary, it took me 2 weeks to implement Babel without any prior experience. And there weren't really any major errors, and only a few omissions in the spec. So overall, I think it's a very implementable spec, and you should all try implementing it. It's fun. Questions? Right.
Dennis, you're up.
Hello, my name is Dennis, and we're talking about security considerations of the Babel routing protocol. I'm not a professional speaker, so I hope you explain my use of the notes. Shall I begin? What I will try to communicate during this meeting is based on my observations of network protocols in general, and I would need to explain that you would need to work with the protocol in an efficient way. You would need to recognize 4 roles of an engineer with regard to the network protocol. That is a user, not the end user, but the network administrator. Then an implementer, that is the person of the company that follows a spec. Then a researcher, which may be an academic researcher or somebody trying to break your protocol or to find ways to make it more secure. That is somebody looking into an existing things and trying to find ways to use them in not the intended way. And finally, the network protocol designer. And those 4 roles, 4 points of view, it's important to recognize that they don't substitute each other. And that takes us to the next slide. I try to avoid comparisons as much as possible, but in this case, I need to compare a few files. Those are files from the TCP/DOM protocol analyzer. And in the first column, you can see the file, then the year when the last update to the protocol encoding was made, number of kilobytes, and the number of lines of code. For several reasons, that's a very approximate estimate, not of the whole protocol itself, but of the protocol encoding. And the complexity of a protocol encoding is meaningful in several ways. One being the protocol analyzer work itself, so that when you want to print the packets, you go on the wire and you want to add support for your new extension to that protocol, you need to make it through, for instance, 104 kilobytes of code, or you need to make it through 23 kilobytes of code. And can we get to the previous slide? In this table, the last protocol, the routing information protocol, is a kind of a landmark. It's not where you want to go, but it's what you want to know where it is, so that you're getting close to that minimum of source code to understand what's going on the wire, 9 kilobytes. That's quite impressive with the latest updates to that old protocol. And here for Babel, it's 24 kilobytes for all of the presently known extensions. And what this table provides is a sense of protocol complexity. Now, why protocol complexity is important is that it's relevant not only for packet analyzers and implementing actual protocols, it's important in the scope of fuzzing. And fuzzing is a technique that allows a lot of computers find a lot of bugs in the source code implemented by usual people, because usual people, they make mistakes. And when they make mistakes and somebody finds those bugs and exploits them in different ways, somebody needs to fix those mistakes. And depending on how complex the protocol and its encoding is, the amount of work you need to do may vary greatly. For instance, you can spend half a day fixing a vulnerability, or you can spend half a month fixing the same vulnerability in the source code written not the right way. And there are ways to make life simpler or not so simpler. And one of the, I have been working with the vulnerabilities in different protocols, and what I managed to see is that it's a very powerful technique, so that those computers, they can find more bugs than you may be able to fix afterwards if you didn't think, or whoever wrote the code didn't think about that in the first place. So the only way to sustain fuzzing in the long term is to design protocols and to implement protocols with that fuzzing in mind. And one of the practical ways to withstand that pressure of all the people in the world running their fuzzing software and finding bugs is on the next slide. It looks pretty much simple, and it is simple in the sense that if you implement a network protocol in the way shown in this diagram, it really remains simple. The first block in this diagram is the first conditional block, which looks like a diamond to the left. It checks if the packet is structurally weighted. That's quite a simple check, and it only stands for you checking that the message really has the size it claims to have, that the structures within the message really have the sizes they have, and that simple things like port number or, for instance, header fields are where they're supposed to be. But that simple check has to be the first check for a reason. And if the packet fails the check, you just discard it right away. And then the bit that RFC 7298 addresses is the check. I'm gonna get back. So the next check is the test whether the packet is authentic. And on the diagram, that's a simple check, but in this case, this diamond in the center incorporates the RFC, which we'll discuss in a bit. And finally, there is the semantics check. That's the most interesting bit. That's where you would check that, for instance, in a message that operates IPv4 routes, actually there are IPv4 addresses, because if the encoding allows you to put things together that were not intended to put together, but still the encoding allows you to make it, you have to account for it. The simplest way is to design the messages such that it becomes impossible to see IPv6 addresses in IPv4 management messages, but sometimes, or rather often, you design the code that protects the main protocol body from fuzzing afterwards. So you have to account for everything, and then in the semantics checks, you would, for instance, check if that's a multicast address, or if the header fields are set the right way, such that they still make sense. And sometimes protocol would embed those checks in themselves, in the main protocol body. For instance, SPF, there are different checks that allow you to tell if that's a valid packet or not. But anyway, you have to make sure that those checks are made, whether they're in the main protocol body or in a separate procedure like this. Then the next slide. This takes us to the origins of this work. It was quite not the way how it was planned, but that's how it was developed. Here is a small story that pretty much speaks for itself. So it wasn't a plan, it was a story, so I could start some bits before I finished the others. And that was worth several months of work, which I started doing fuzzing protection for OSPF, and that slowly evolved into security extension of Babel. And the result of this was the internet draft that was submitted in 2012, the first version of it, and then followed pretty much usual story of evolving an internet draft to an RFC. And the next slide takes us to 2015. When RFC 7298 was already published, and a considerable amount of time later, there was another RFC, which I was working in 2012 and 2013, because what RFC 6709 discusses about cryptographic agility, it discusses briefly and not in a way that you can understand after you read it once or twice. You have to think about it and apply a great deal of interpretation. So that's what I did. And in 7298, there are provisions made based off what was available at that time on 6709. Then in 2015, 7696 was available, and I was glad to discover that my work remains in line with the BCP. And on the next slide, you can see how exactly it remains consistent, which in practice means slightly less work for the working group, because on the list of items to be done, there will not be things to fix inconsistencies in 7298 with regard to cryptographic agility. Because, for instance, parameter size, ICV, which is integrity check value, the size must be identified. And in RFC 7298, it's identified for the simple reason that the parameter size is correlated with the padding procedure, which needs to account for IPv6 addresses, which are 128 bits long. So that's there is a normative text. There is a text in 7298 that discusses these requirements. So that's an example of how the requirement is met. And another example would be two independent MTI algorithms. And there are two algorithms, and they are explained. It is explained how the operator would change between those algorithms, because the security associations that 7298 operates, they include an explicit field for their protocol ID. And moreover, in the packet encoding of 7298, there is a requirement to support at least two integrity check values per packet, which means that operators would have much more convenience for switching between algorithms or keys or algorithm and the key at once. That has been provisioned, and that's, in my opinion, that would be convenient for the working group to use something that doesn't require fixing in the first place. And so on as those are good news, there are some not so good news. And on the next slide, we come to the question that people would ask. And the question is, can we just take this specification and use it, and it would solve all the problems? And the answer is no, you cannot, because it doesn't solve all the problems. And
Dennis, we have a small problem. We're starting to run out of time for the charter discussion. And you have some really neat slides following this, but we need to move along.
how many minutes have I got?
How fast can you go?
Okay, on the next slide, you can see how exactly it's not perfect. There are four routers here, and what you don't see on the slide is a mountain in between, in the center of the slide. so that the routers are working around the mountain and they're connecting to networks. Then some resourceful guy gets to the mountaintop and mounts a repeater. And that repeater is specifically configured to relay only the Babel and ARP and neighbor discovery packets between specifically neighbors A and B. And the consequence of this is that those neighbors would use the short link between them to establish their neighborship. And the problem is all the payload from A to B and the other way around would be backhauled. That's link spoofing, and that's how it works. And it works the same way not only for Babel, but on the next slide you can see how it works for BGP, for instance, where two routers think they have a direct link between themselves. They maintain a BGP session, exchange routes, and they drop traffic in one direction or both. Unfortunately, that's a generic problem. So on the next slide, you can see a longer version. On the next slide, you can see a longer version of the same answer that explains that the problem is generic, or in other words, it's more complex than it's more complex in general. So that the fact that for Babel, its security mechanism cannot cope with this problem, it's just a case of its generic complexity, and many other protocols cannot cope with the same problem as well. Now we come to the conclusions, which are pretty much what has already been said on different sides, except I would like to add that I would like to add that in the scope of the working group, it would really help to have cryptography experts, or it would be reasonable, or the working group may decide it to declare it reasonable to have an applicability statement of sorts with regard to the security extension, so that when the problem is understood, you can describe it, and even if you don't have a solution, you can clearly describe that for this specific problem, there is no solution. That's, for instance, the way that is done in the Manet working group. They have the same problem, and they decided to come up with the security threat analysis that confirms the problem and tells that there is no solution. And, or alternatively, some smart guys can come up with a different solution and implement it, and I would be glad to see it myself. Then, and okay, I'll skip what else I was trying to say. Thank you for your attention, and if you have any questions, do we have time for questions?
There's a few questions we do have. I know we need to move on, but one or two questions I would take anyway. Okay, we're going to move on.
You can ask in private or on the mailing list if you want later.
So the main thing we're going to need to do, thank you very much, Dennis, is I want to review the charter so that we have a little context, so I can then ask you guys the question, are you interested in actually working on this? Are you going to contribute? Do people want to see this move forward? So I'm going to try to go through these. I've decomposed what's in the proposed charter into a set of slides. If you see issues with them, come up to the mic as I'm going through. This is the time for discussion. We've got 15 minutes left. It's for this discussion, because this is the most important part of the whole thing from the IETF process point of view, not from the technical substance point of view. I don't think there's much point in discussing this particular slide. This is the overview as it exists, and love to, if there's feedback that says we got the overview wrong, we can discuss that on the list. That's much less of an issue. So, and my machine is not being cooperative about what it displays, but the goal is to go to PS. That's what we've been talking about. I believe everybody's understood that. So what do we have to do that? We have to incorporate anything that's been found since Julius wrote 6126. That includes the extensibility from 7557 and anything that the experience that Tokay was talking about told us about, or any issues we find. If the working group will engage in technical discussion. I'm not going to say this is the precise list of issues. The charter doesn't do that. It says technical issues are what the working group is going to work on. That's what we usually work on. So this is the top line item in the charter and is where our focus is going to be, unless somebody comes up with some very different way of looking at this question. We obviously need, and that's why we had Dennis doing this presentation, to make sure we address security in a solid fashion. It may be a companion spec because just length of specs, we want them separate, but it will be normative, it will be referenced, it will be tied together, and it will be analyzed as part of the whole solution, not, oh, we finished Babel, now we can work on the security. It's part of the same discussion. And so we're likely to build, the expectations we're building on 7298, but getting all of the input from all the security experience we have here to see what we need to do with that. Applicability and manageability are things that we as a community expect of working groups. So we're going to have to do that. That's why Julia started the applicability spec, and we are going to have to address manageability. Yes, it works out of the box, but there are knobs that people want to adjust. There are things people want to be able to monitor. We're going to have to define that. This is a task most routing area working groups hate to do, but have to do. It's actually important to make this operational. And the way that seems to work for the IETF is to produce a Yang model. I'm not going to debate about Yang versus other choices. This is what works for here. I expect we're going to find we're going to do that. There are a couple of things we listed in the charter that may be done in parallel. They may be done later. And that's, it's going to be up to the working group. For example, we could take Tokay's talk and other things as people go forward and turn that into an informational RFC. That could be very helpful to folks to understand, how did we get here? What did we find? What are hints? They're not part of the normative specification, but they're things that are helpful to understand. Real world experience is very valuable. I would hope the working group will do this, but it's not mandatory to get to PS. And as was mentioned by Tony, there is the question of multicast. We may well say that comes later, but if there are enough folks who are actively interested in doing it in parallel, we can do it at the same time. It's not a showstopper. My first thought when this was brought up was, whoops, we need to deal with that. But in fact, lots of routing protocols deal with unicast and then deal with multicast. And so while multicast is important, we can figure out how to deal with it. So that's what's in the charter. Of course, it does end with coordinate with other working groups. This is not an isolated farm. This is part of a whole environment. We work together. That's the way it goes. Now, before I start asking the room questions, are there comments, opinions, questions on this chartering?
Yes.
Your name, please.
Take a boat. My question is about the protocol and how the drive for this protocol is MANET. Is HomeNet. Oh, I'm the MANET guy. Sorry. Most protocols in IETF can be tuned, and there is an administrator for that. Now, the administration task is plug in the power plug for the home router user. Now, the protocol can be tuned, for example, timers, metrics, costs. But now there is no administrator, and I think we have a new task within IETF to define something about, for example, metrics. What is the cost value, for example, for a Wi-Fi link, for an Ethernet link, for whatever link? In normal networks with normal administration, the organization itself sets some scheme up now this is missing. So we as IETF are facing a new problem. So this zero conf thing. So I think it must be on this charter of this working group, or maybe it's something to put in the home net, and then we keep the protocol somewhat clean for networks that have management, and that the protocol allows tuning. So
Can you send a summary of that thought to the list? Because I'd like to see it in writing to see how we could incorporate that into the charter description or the milestones. It sounds like an interesting question we should at least discuss on the list.
David Lamparter. It's unclear to me what the multicast item on the charter is supposed to mean, because I'm trying to interpret it, and I can come up with either trying to use Babel to calculate a multicast distribution tree, or I can come up with using Babel to do a separate topology, or maybe there's something completely different.
So the question that was asked was, how do you use Babel to do routing of multicast traffic?
Okay, so it's
But that's why we put it as a
generic
separate
sense,
item, because it may be we want to deal with that as a separate question or don't even want to deal with it. We're not requiring the working group to address it, but we wanted to put it on the table so that if the working group did want to address it, it was in scope. Because what's completely out of the charter, we won't be discussing, no matter who your chairs are.
Fair enough, I get that. Cool.
The name of your name, sir.
Kiriti Compella. I still don't know why we have this protocol and working group, but I think it would be a good thing in the charter as an item, as one of the things that we do, to say why for this particular application, OSPF wouldn't work, RIP wouldn't work, ISIS wouldn't work, BGP wouldn't work.
Okay.
And to have a coordination.
Kiriti, let me separate two things. We did discuss just now that we'll have an applicability statement, what this will work with.
Yeah.
I have never seen success in the IETF with a working group trying to say what is bad about some other working group's product. It doesn't work well for anybody, and I would recommend we not go there.
Oh, okay. So people are going to ask the question anyway. So it would be useful, I think, and this is where the coordination would be important, to say why it won't work. And you might say it won't work, but I think people are going to say, why don't we use OSPF here? Why don't we use RIP here?
I could ask the same thing between OSPF and ISIS, and we'd be at it forever. Let's not go there, Karina. I need to hold the line for just a minute, because I have to make sure before people start walking out at the end of the session that I get some questions asked, but I want to give you guys the chance to ask some things too. So I'm going to ask you to just wait a minute while I do a very quick poll of the room before people start running out. How many people in this room, if we had a working group, would be willing to work on writing text? Okay, I see 5, 7, I see 8 or so hands up, maybe 9. Now put those hands down. People who are not willing to write text, how many people would still be willing to actively engage and review and send comments and participate if we had the working group? I see another larger number. How many people are in the final question, which I want hums, not hands. I want a hum so that we can hear it. Hum if you are interested, if you think it would be worth forming a working group to work on this. Conversely, hum if you think it would be a waste of time or a bad idea or any of the other negatives you care to apply. Okay, now we can go back to the line. I'm sorry to have to slow you down, but I needed to make sure. There was a large hum of interest and a very small hum of negative. It was non-zero, but it was small. If you don't know, you were counted in the silence. We're not trying for precision here. I was getting a sense of interest.
Barbara Stark, to the topic of manageability, since the most likely managed device would be the ISP provided router, and While there is a service provider who's suggesting using NetCont for managing such a device, there are millions upon millions of TR69 managed devices. So I would suggest that we start with an information model that could be percolated to TR69 and to Yang. And I would be perfectly happy, as someone who volunteered to write text, to specifically work on that.
Okay, please make sure that's in the minutes because I got to update the charter to reflect that idea.
Michael Benson. So to the first question there, so the current implementation of Babel does some of the tuning and stuff on its own that I didn't see mentioned here. Do you see other stuff being added to the charter here for that kind of things, or would that happen in other places?
The charter is going to define what the work is done first to get this to PS. My guess, I'm not the charter approver, I'm not the eventual working group chair, is that we will want to focus this so that we get PS done. I'm not sure, I may have misunderstood your question though, but
okay.
there's certainly
So
plenty of other
ask,
things.
If I can ask.
Julius Krobacek, it's already in the charter when it speaks about metrics.
Okay.
That's where when the tuning is hidden under the notion of metric.
Oh, okay, so the fact that it does try to auto-deduce a metric from a link quality heuristic, it's already in there. Okay.
Hi, David Skenazy from Apple. I just wanted to say that I've been playing around with this and strongly support it coming together as a working group, because from the enterprise side, it's always better to have some place at the ETF where we can come to with suggestions or issues.
Define playing with it.
I'm sorry, I won't be able to do that.
I don't think, let's let it go. I think that is a useful comment. Thank you. Bob.
Hi, Bob Hinden, and I do not work for, the company I work for does implement routing protocols, but you wouldn't call us a router company. So I support this work. I think it's very cool that the IETF is, I hope, going to create another routing protocol. The last ones were created when I was the routing AD, and that was, a long time ago. So
you preceded me.
No, I had more hair. Two things on the charter I'll just ask about. So I don't think we should get I sort of see this as used in unmanaged environments. So spending a lot of time on how to, manage it may not be that important. And then in those environments, multicast may in fact be more interesting. So I sort of maybe give different priority to those.
Okay.
In case you couldn't see it yourself, I have counted 8 independent people or 8 independent logins of some sort hummed in the Jabber room.
Oh, thank you.
For the hum. And also Dave Tat had a question, which is really a statement. While I'm okay with the basic chartering, I too would like zero confish and L2 issues to be explored. Babel over 802.11, 6LoWPAN, 802.14, Mocha, Ethernet over Powerline, and yeah, Ethernet, and a bit more interaction with the IEEE at layer 2.
Can you email those to Tim so he can capture them? Okay, perfect.
Adrian Farrell. Firstly, it's nice to see Bob back in routing. We have actually been doing stuff in routing since he went away. We have done other routing protocols in the last 45 years. I have a concern about the charter text as it stands, and I know it's sensitive, but it is an elephant in the room, about when we say we're taking on and standardizing Babel, there is a risk that we are simply documenting Babel as a standard, and I know that many people intend to read this as we are going to do whatever is necessary to modify and adapt and extend the protocol such that it is standard. But we must not confuse that end product with Babel as it is today. And that needs to be reflected in the charter text. Otherwise, somewhere down the road, we will be seriously hosed.
I believe that we're in agreement about what has to happen, Adrian. If you can see ways to improve the charter text, send some text to the list, because the intention is the working group owns it. The working group is free to make changes to address technical issues, to do things that working groups do. Not because we just decided to flip the bits upside down, but we try not to do that. Go ahead, Samita.
Samita Chakrabarti. Just a suggestion that you are saying that Babel will develop a problem statement, and I would like to add a scope for the use cases, because I heard it might be applicable in home networks, enterprise networks, and maybe for scalability of wireless mesh networks. But I would like to understand whether it could be, we could even extend its range to, say, low power networks or such. So, having a clear problem statement, scope, and use cases. Thanks.
Just a quick one, Joel. Tim Wasinski. I've been taking the minutes. If I may have spelled some of your names wrong, so I just urge you to go to check out the Etherpad and please correct my misspellings, and I apologize for that. That's all. Thanks.
Thank you. And thank you very much for taking the minutes again, Tim. Thank you all for attending. We are done. You can go try to catch some break before it disappears.
Of right, the new Babel implementation. Okay, thanks. They were civilized. I would say they were very productive.
Kariti tried to take us off into the weeds. Kariti tried to take us off into the weeds. He knew better.
Yeah, but he knew that he didn't go nowhere with it, right?
Yeah.
So